The sensitivity analysis will enable you to view all formula instantly. As you can see here, when you scroll down, this shows you all the steps and all the answers to all the formula. It's got them all in all the steps that you've done, all the formula are carried out and they're put into this sensitivity analysis. For example, it shows you here the convective heat release rate for both formula down here, with the answers to both formula. Now, if you wish to vary any parameter at any time, all you simply do is click on the formula or the link next to it, and this brings up a pop-up. Then you can insert the new values and press update. Once you do this, then you press close. It automatically closes, but it automatically updates all the formula in this page with the variable in it. So any variables you change on the pop-ups, when you press close, it closes down and it updates all the formula with that variable in it. So you can see at the touch of a button the impact of varying any parameter. It also covers step 3 here, as you can see, the mass flow rate of smoke. It shows you the various methods available to determine the axisymmetric simple plumes, both near and far field models. Now, the big thing about this sensitivity analysis, it also shows you when a particular formula is valid and when it's not valid. Can you see here, these aren't valid or that's valid? It tells you if it's valid or not valid. Now, if you want to see the limits of validity for these formulas, in other words, why is it not valid or why is it valid, all you simply do is click on the formula link, as you can see, and then you click on the V pop-up link. This will create a pop-up which identifies the limits of validity. So in other words, these formulas, the formulas on here that have got limits, we have identified those limits and we tell you when it's valid and when it's not valid. So if someone submits a scheme, you put the data in and they're submitting a formula that's not valid for those parameters, our calculator will tell you that's not valid. So you can go back to the engineer, you can't use that far field model, this is a near field. Do you understand? It tells you when it's valid, when it's not valid. This is a very powerful tool for the industry to make sure that the formulas that are applied are correct. Now, if you scroll down here further on, you see a line plume. In this case, there's only 2 models available. Then you go for a wall plume, there's 3 models available. Finally, you see the models available for corner plumes. In this case, there's 4 models available. There's 2 near field and 2 far field. And again, it will tell you what's valid, what isn't valid, and it gives you the answer to all of them. Now, as you scroll down, we're moving on now to complex plumes. This one here is the mass flow rate of smoke out of the opening. As you can see, there's 3 models available. 3 models for working out the mass flow rate of smoke out of the opening. Now, the most commonly applied one is this one here from SIBSI. This one here. MO equals 0.009 times QP times WO squared, all to the power of a third times HO. This tells you now, as you can see, this is not valid. So if someone submits a proposal with these parameters, it will tell you it's not valid. Why isn't it valid? Let's have a look. Click on the formula, that brings a pop-up. Then you select the V icon, which points out that this formula is valid only when the width of the opening is greater than the height of the opening. So let's change the variables. If we select a width of opening of 5 metres and a height of 3.2 metres, and then we base it on a convective heat output of 4,200 kilowatts, this equates to a mass flow rate of smoke out of that opening of 13.58 kilograms a second. When we select close it, it updates the formula, and as you can see, this is now saying this is a valid formula. The enforcer can accept this model. Moving on, we find here part 2, the mass flow rate of smoke under the balcony. This shows you here the depth of the smoke layer under the balcony. So from this you can work out the depth of the smoke layer, which is required in other thirds calculations. Now, the next area is the complex plume models, of which there are 4. Again, not only does it determine all the models with the various inputs, as it shows highlights here, it also shows you which ones are valid and which ones aren't valid. So some of these are and some of these aren't valid. At least you know which are valid. Now, all you do with the rest of this page is scroll down and carry on all the other checks, inserting data when required. You can choose a pop-up whenever you want. You can change any parameter whenever you want. This allows you to play with the calculations to make sure you get the optimum design.